Okay, so first thing is for the really 13.1, we're going to back up for just a minute and get a few definitions for some things that we need, and then the rest of the time we're actually going to work on the graphs of the sine functions. First thing is when we talk about periodic functions, and I'm trying to go back and remember because we bounced around a good bit to see, but I think when we talked about functions in the first part, it kind of spins off this one. Basically, is this: these are functions that have repeated y values. Because one of the definitions of functions way back when was that if it's almost easier to talk about what something is not a function. If you talk about ordered pairwise, if we were talking about like 2 4s for this one, something that would make it not be a function was that if you had 2 4 and 2 6, basically if you had the same x value with two different y values, this thing would not be a function. So this one is saying, all right, if we start talking about the y values that go along with these numbers, we're going to get repeats of it. So basically what we're talking about in this case is it's kind of like the unit circle. Is that is we keep going around the unit circle. If you talk about the values of 30, 45, and 60, all these will go around. Once you get past 360, this would be like 390, 405, that the values would just keep repeating. You keep going in this cycle, keep going in the same pattern. So basically the unit circle is basically a periodic function because no matter what you do, eventually you're going to come back to these exact same numbers for your y values. And that's kind of what it's saying in this case, is kind of what we're looking at. So. All right, the other thing we're going to talk about is a cycle. Not a motorcycle or a bicycle, which I've never understood why you have to say those two things differently, even though they're the same word there. But a cycle is just one complete pattern. And for what we're talking about, we're basically saying like one trip around the unit circle. If you want to think about it that way. Doesn't have to be, but because we're talking about the trig part of it here, then that's really what we're thinking about, is that it's one time around the unit circle. Okay, and then the period, well, that's the horizontal length, if we could stretch it out horizontally. And because we're still thinking about the unit circle and how this is doing, that basically this is the circumference. Now, and that will change depending on, if we change it where it's not just necessarily a unit circle, we'll just change it to where it's a circle, or maybe the radius is not one. We'll do some things differently, but it's going to kind of give us that idea of what we're doing. And then the last thing we need here is the amplitude. And that is the vertical length from 0. Okay, and I used to have a poster in here, kind of change things out every so often, but there was a poster in here that had showed somebody playing, I think it was guitar. You could do the same thing with a piano. You could talk about, if you're a trumpet or if you're a drummer, something where you're making sound. Sound, when it travels, it doesn't travel in a straight line. It actually travels in a wave, and that's what we're going to look at today when we do some of these. And when you talk about amplitude, well, that's how far this wave kind of moves up and down. If you think about an amplifier, if you're playing an instrument, it's kind of that same way that, amplitude, amplifier, it kind of goes along that same effective what we're talking about it. Okay, so that's everything, kind of the background that you need for 13.1. For 13.4, this is the sine function. And this has got one specific graph that we're going to look at for this part of it. Once we got the basics of it today, tomorrow we'll talk about the cosine part of it, which is similar, but we just got to tweak it just a little bit. And there's one basic, well, actually two, I guess. one formula which has got two versions of it where we tweak it just a little bit. You could do y is equal to a times the sine of bx. But a lot of times they don't use x in this case when we're talking about sine functions because they don't want to get it mixed up with the ordered pair. So a lot of these problems you're going to see it where they're going to have y is equal to a times the sine of b theta. They're going to use theta for instead of x in this case. It's the same thing. Whether you see theta or x, it's the exact same question, just a little different way of them writing it. Okay, so going back to what we had up here with the period and amplitude. If you do the absolute value of the a value that they give to you in this equation, that is the amplitude. Okay, so A stands for amplitude. All right, and the B part of it, which is not by itself really important, but basically the B part is the number of cycles that you would go through. And really what we're going to use the B value for, the most important thing off of it, is that that tells us what the period is. And the period is 2 pi divided by the B value. Okay, and that's really the two big ones that we need. We need the amplitude is kind of a big value, and then the period is also the big thing that we're going to do. All right, graph-wise. If we'll lay out all the graphs and have them kind of be perfectly done for this thing. And here's where we're going to kind of go back for just a second. Again, all we're going to need is, it's more of on an XY axis for this thing. Stretch it out more to the right side because of the way we're going to do this. That we're going to break this thing down so we get it so we're only going to do one cycle or one pattern for this thing of it. And if you think about that, we're talking about sine. Go back to unit circle for just a second. Sine is your second number. So when we start over here, sine starts at 0. So when we start this graph, we're going to start at 0. Okay, and basically the top and bottom of the graph, the A value, that's telling you how far up we're going to go and how far down we're going to go. So you can basically make the top A, you can make the bottom part of it negative A. And if you look at your sine values, which again is just the second number here for the Y part of it, we go from 0 up to a half, 0.5. If we do square root of 2 over 2, that's like 0.7. If we do square root of 3 over 2, that's like 0.8. If we get to this, when we finally get to the top, we get to 1. So when we start graphing these numbers, they keep getting bigger and bigger and bigger until we get to the top of the unit circle. And once you get to the top of the unit circle, the numbers start to get smaller. And it's back to 0.8, back to 0.7, back to 0.5, and then it's coming back to 0. So we're doing something like that. Okay, and then if you keep looking at your Y values, well, now it's negative 0.5, it's negative 0.7, it's negative 0.8. It bottoms out at negative 1, which you can't see there, sorry. Bottoms out at negative 1, and then the numbers start to come back up till you get back to 0. So if we graph this part of it, this is where it kind of bottoms out at the bottom of the unit circle. And then once you get to the bottom, then you're moving back up towards the top. Okay, and whatever you get for the period, the 2 pi over b, once you've kind of done one complete unit circle where you've done the top half of the unit circle and the bottom half of the unit circle, you're going to wind up at this point, which is 2 pi over b. Okay, now, and here's the difference of whether we're in class or now with this test being online. If we were going to be in class, we would really focus in on what these other three values are back here, and we'll do that in a little bit on the next problem that we do. But as far as what we're going to do online, those 3 points back here may not necessarily be important, but really you just need to focus on where this thing ends, because that's going to be where the period is and where this thing ends, that's going to be the most important number that you're going to look for. And I did the best I could with the graph questions. Some of them aren't the best in the world, but there was only a certain number I could pick from. So tomorrow when we start doing some of these, if you get in class and you get stuck on some of these problems, this is one where I don't want y'all to just keep hammering yourself and try to keep doing this thing over and over and over. Let me help you on these graphs, because some of them, they're just hard to read because I couldn't find that many graph questions. So I picked the best ones that I could, and even some of those were a little iffy on some of those parts. So as we start working through some of these problems in the next couple of days, if you get stuck on something, bring it to me and let me help you out with it so I can help you walk through it, because they're not the best questions that I could find. They were more like just the only questions I could find when it came off of it. All right, so let me give you some examples. We'll do like 4 of these so we can kind of make sure everybody's got an idea of what we're doing, and then we'll wrap it up for the day. Okay, so y is equal to 4 sine x. All right, so what we'll do for this one, again, just kind of pick out the easy parts of it here. Whatever's in front of the sine, that's your a value. If there's not a number back here, then it's going to be understood 1, because it basically would still be 1 times x. Just like if there wasn't a number in front of this one, then the a value would understood be 1, but we've got the 4 that's here. Okay, so amplitude. Well, that's going to be the absolute value of 4, which is 4. And again, the b value by itself it does give us something with this part of it, but really what we need is the period, which is 2 pi over b, which is 2 pi over 1, which we go, okay, well, that's not bad. That's just 2 pi. Okay, so graph-wise, here's where we're going to go back. And again, we'll get the basic part of it, and we'll go back and kind of get the details on whether these parts would be back here. So if the amplitude is 4, top of the graph will go to 4, bottom of the graph will go to -4. And whatever this number is, that's the period, the 2 pi, when we get finished with the graph, that's where this thing would be. Okay, so here's what we know. That if this is where we know this ends at 2 pi, we basically would draw top half of it here, bottom half of it there. Okay, now here's where we'll kind of use the other parts and pieces of it, because most people go, well, that's not bad. And yeah, if we took these parts off, you could always do an easy graph like that to go through that. Now, when you go into the pre-cal, sometimes they make this may go more than just the one cycle. Sometimes you may have to go, 2 or 3 or 4 times through it to get the full graph of it, depending on what the whatever your period winds up being back up here. We may have to do it differently. But for these, we're pretty much just going to have it so we're going to do one cycle. We're just going to go up and down and end up at this part of it. Some of the graphs, again, it may not exactly always end perfectly where you have one like this. Sometimes it may be that we're going to do these and the graphs may be a little bit different. To kind of get, if you need to know where the top of the graph is to kind of figure out what this one is, because sometimes they may give you some options and it may be hard to see. But basically this first mark that would be right here. So if you want to find this first mark, that would basically be where the top of the graph is, because sometimes the way they do this, they may key on different parts of it. But if you want to find out where this first mark is, which would be the top of the graph, we know it's going to be at 4. If we got to here, we know what the 4 would be. We need to know what the x value is, maybe, the way they've got this graph is. So to find the first mark, it equals your period divided by 4. Because if we know where it ends, because we've got this number that's here, basically we're going to make 1, 2, 3, 4 pieces and cut it into 4 parts. So the first mark is always going to be this period number we get here divided by 4. So that's 2 pi divided by 4, which would make it 1 pi over 2. Now, the one thing we're going to do for what we were doing, if we were doing this in class, we'd make it kind of easy this way, is that this first number would be 1 pi over 2. And again, for us, we'll make it work out this way. If you get into pre-cal, it won't always work out this way because we're just kind of setting it up. The way the next number would be, it's going to be 2 pi over 2. But then we go, oh, well, the 2 over 2 cancels, so that means this next number is just pi. And then the third number is going to be 3 pi over 2. Okay, so if you need to find those important marks where we're doing for hours, it's always going to work out that it's always going to be 1, 2, 3 when you go through these numbers. So whatever your denominator winds up being, it's always going to be 1 pi over something, 2 pi over something, and 3 pi over something, and you just got to go back through and simplify the ones that you can. Sometimes you'll be able to simplify some of them. Sometimes you may not be able to simplify any of them. You just got to kind of go through and simplify the fractions out to get through those. Because some of the graphs, again, the way they match up is not always perfect. So sometimes you got to kind of dig in and find some numbers in the middle, and that's the way to kind of go through and dig in and find some of the numbers in the middle. All right, let's give you another one so we can kind of just keep playing around with these. All right, so for example 2, let's just switch it up a little bit. And instead of having 4 times sine x like we had on this one, let's switch it up and let's make it the sine of 4 times, instead of x, we'll say 4 times sine theta. Okay, so now we're just flip-flopping the values. Now the a value is 1 and the b value is 4. Okay, so the amplitude is the absolute value of 1, which is still just 1. Okay, that's always the easy part. And for the period, that is 2 pi over b, which again is 2 pi over 4, which is 1 pi over 2 or just pi over 2. Okay, and again, what you're looking for on this one, and this is kind of the first thing you want to look for, if you're doing these online, is that you're going to have, unit circle looking type problem. And the main thing is that when it stops right here, that this is going to stop at pi over 2. So that's the first thing you want to look for, is that that number ends at pi over 2. Sometimes, though, they may not have it so that thing ends exactly at pi. I mean, they may not show this number. They may have it so that this thing is set up so it's in like pi over 3s. So maybe this is like 1 pi over 3 is here, and then you got 2 pi over 3 is here, and then they'll eventually go back and put pi back over here. So maybe that it's not always spread out exactly like it should be. So this is where you have to kind of go back and try to figure out some of these other spots would be here. So you need to kind of figure out where the top is, the middle, and then at the bottom. Because again, how that they label these, sometimes it's not always the most perfect thing in the world. So this is where sometimes you got to kind of go back and dig into it and figure out what it would be. Okay, so again, just making sure that we can find some other numbers in case we need it. Again, if you needed this first mark where the top of the graph would be, we're going to take the pi over 2, that would be the period, and we're going to divide it by 4. If you have a fraction like this, the other one was okay because when we did the first one, we simplified it down, no problem. If you have one like this where you already have like you got a fraction with a fraction here, the shortcut is you just multiply these two numbers together. So if you take pi over 2 and divide it by 4, again, if we go back to like 6th grade math, 7th grade math, when you do the keep it, change it, flip it thing, basically it would be pi over 2 times 1 over 4, so that's going to make it pi over 8. And again, if you want to think about it this way, this is technically 1 pi over 8. This next number would be 2 pi over 8. But you can simplify the 2 over 8 to make that pi over 4. So this is 1 pi over 8. This is 2 pi over 8. The next number would be 3 pi over 8, which won't simplify. So we've got that mark here. And finally, that last one, we already knew it was pi over 2 because that was a number that we had that was right here. Okay, so that's more of just kind of helping you along the way with some of the online homework because they may not necessarily have it. So this is pi over 2. They may break it down so that it's, pi over 3 or something like that. And you go, well, this is at the bottom. That's pi over 3. Well, that's pretty close to pi over 3. 3 pi over 8 is getting really close to pi over 3. If that was 3 pi over 9, then we've got it. So that's pretty close to it there. All right, let's give you a couple more of those. All right, so for this one, let's go with 1/2 times the sine of 2 theta. Okay. And again, just get the A and B values out of it first. A is in front of the sine, and then the B values, whatever's behind sine. All right. Amplitude is the absolute value of 1/2, which is just 1/2. Again, the B value helps us find the period. So for this one, because we'll do 2 pi over 2, 2's cancel, period's just pi. Okay, so again, if we run this thing out to the period, top half of it here, bottom half of it there. Okay, and I know first block, that's what some people were asking, like, what does the pi do? Well, the pi tells us, whenever we do the period, that tells you one complete trip around the circle. There's the top half, and there's the bottom half, if you want to think about it that way. Okay, and again, some of these, they may not necessarily always mark it the best in the world, so it might be good to know where the top of the graph is. Maybe we need to know where the middle is. Maybe we need to know where this thing bottoms out, so we have some idea of what we're doing for these. And if we do that one based on these numbers, again, because if we think about we always cut it to fours. We said start at 0, 90, 180, 270, and then once we got back to 360, we started back over again. So this one, same thing. For our first mark, we're going to take the period and divide it by 4, which in that case turns out nice because it's just pi over 4. So that was just the period divided by 4. So in that case, it's pi over 4. Nothing to simplify, so that one's good to go. All right, but again, if this is 1 pi over 4, the next one would be 2 pi over 4. But we can simplify the 2 fours to make that one pi over 2. The next one would be 3 pi over 4. And we've already got the fourth one, which would be 4 pi over 4. But again, the 4's cancel out. We just get pi. Okay. All right, last one we'll do for the day. All right, we'll do -3 times the sine of 8 theta. Okay, so our A is -3, our B is 8. And again, for the amplitude, that's the absolute value of -3, which is just 3. Okay. And our period, again, is 2 pi over b, which is 2 pi over 8. We can simplify that one down to make it 1 pi over 4, or just pi over 4. All right, now this one does have one thing that's different from this problem than all the other problems had. And this kind of ties back in with some other stuff. A value is negative, right? So what happens if this number came out, let's say we went back to sine of 8 theta and this number was positive. What happens if you do a negative times a positive? Makes it negative, right? So this time, all the answers, before when we were doing this one, all the answers started off positive. Well, if you start the number off with a value is negative, now the first numbers are always going to be negative. So instead of going, it's kind of like if you think about a value, which we'll talk about more with quadratics coming up, it's kind of like slope. That if the a value is positive, we had to go up. If the a value is negative, we've got to go down. So since the a value is negative, we're going to go down from the start. So again, if you think about a kind of being like the slope, it tells you which way to go. So if the a value, if you think about y equals mx plus b, the number that we had back here was always telling us, what to do with it. This one's kind of the same thing. This number in front tells you kind of like slope. If it's positive, you got to go up. If it's negative, we've got to go down. So the only big difference on the graph this time is instead of doing the top half of the graph first, well, now we're going to do the bottom half of the graph. So now we're going to go down and up and then back around to there. Still the same numbers. We still got 3 at the top and -3 at the bottom. It's just now because the a value is negative, instead of going up because if a negatives, then we got to go down. And again, because this number is pi over 4, we're going to stop at pi over 4. Okay, now in some graphs, it may be that once you know that this thing ends at pi over 4, that may be enough. But some of the graphs, they may not necessarily be, the numbers may not always be very nice and neat. So again, to get this first mark that would be here, is we're going to take the period that we have, the pi over 4, we're going to divide it by 4. And again, the shortcut is that if you have pi over 4 and 4, you just multiply these two together. So that makes it pi over 16. And again, for all the ones we're going to do, that it will always be 1 pi over 16. The next one would be 2 pi over 16. The next one would be 3 pi over 16. Again, technically, if we were doing this one, it would be 4 pi over 16, but the 4 over 16 would simplify down to just a pi over 4. This one's okay because it's pi over 16. This one we'll have to simplify it and make it pi over 8. So it'd be pi over 16, pi over 8, 3 pi over 16, and then pi over 4 for the numbers if we were looking at it.